All right, we're continuing on assignment 311 here, picking up with question 9. So our derivative of an arc sine is 1 over the square root of 1 minus that glob squared. So I'm going to square it right away. That binomial squared, x to the fourth minus 2x squared plus 1. And then times our chain rule on the glob will be a 2x. So the reason I know to do that is because this positive 1 and that negative 1 are going to cancel. And then notice that the two terms that are left, I have to distribute the negative sign. But notice they both have an x squared. So you could take an x squared out of both of those. And if I turn around and make the negative one, the double negative positive, so I'm going to reverse the 2. So do you see that I factored an x squared out of each of those two things and then just swapped the order? All right, well, the interesting thing here is to remember that the square root of x is not just x. It depends on whether x is positive or negative. So the square root of x squared is the absolute value of x. So we could stop here, but remember this function, we know what that looks like. I'm going to erase this in a minute. But we've seen that that function many times looks like this function. So at 0, 1 and at 0, negative 1. So that function either has a value of positive 1 or negative 1. So in GeoGebra, we saw that changed to a function that is kind of common, called the sine function. So that x over the square root of x. So that's a good chance to remind you that you might sometimes see functions written differently. So I think either of those last two forms. All right, let's proceed with finding the equation of a tangent line. So we've got our point of tangency given for us, but we now need the slope. So the derivative of arc cosine, I'm going to leave this 3 out in front of our derivative. The derivative of arc cosine is a negative 1 over the square root of 1 minus the glob squared. So I'm going to square that x over 2 right away. And then a chain rule. The chain rule on x squared, remember x over 2 rather, the chain rule would just be a 1/2. So now I'm going to put this together, so that I don't lose it later, I might bring that negative sign out in front. And I guess I want to put that 3 in the numerator. And then this 2, I'm just going to move over in front of the square root. And now this 1, I'm going to rewrite that, you've seen this in one of the previous problems, as 4 over 4. So that I can remove the complex fraction. So now I can factor 1/4 out of each of those terms. And the square root of 1/4, of course, is 1/2. So these two terms cancel nicely. So for our y prime, our formula for our slope, we have negative 3 over the square root of 4 minus x squared. So now we want to find the slope of the tangent at this particular point. So our y prime at the point 1 pi, so we can use that such that bar. Our y prime such that x is equal to 1 and y is equal to pi. We would simply put 1 in for the x coordinate. So our denominator will be the square root of 3. And that certainly is not in simplest form, so let's rationalize it. So notice we would get negative 3 square root of 3 over 3. So our slope is negative square root of 3. So now our tangent line, we've got our point of tangency up above, and now we have our slope. So our tangent line would be y minus pi is equal to negative square root of 3. Quantity x minus 1. And that's the equation of our tangent. All right, what we've got left to do is to prove a couple of these formulas. And why is the derivative of inverse sine what it is? So how could we do this? Well, let's start by writing an inverse sine equation. And then let's change it to sine. So remember, inverse means that this is the answer, excuse me, and y is the angle. So let's rewrite this as sine of y is equal to x. And now let's draw a diagram. So let's draw a diagram of an angle where the sine of y, that seems unusual because usually we use x as our angle. Here y is the size of our angle, and the sine, which is the opposite leg to the hypotenuse. So the opposite leg is the vertical length x to the hypotenuse 1. So we've got a right triangle that satisfies our problem, and if we did implicit differentiation on that equation up above. So now let's do implicit differentiation. So the derivative of sine is cosine of y, and then chain rule on the y is equal to the derivative of x is just 1. The chain rule we don't need, of course, that would be a dx dx. So our derivative is 1 over cosine y. So we're still not where we want to be, but if we simply look at our diagram and substitute, so let's go back to our triangle and let's find out what is the cosine of y. Well, we would need to know this adjacent leg, but that's easily done. We know Pythagorean theorem. So temporarily, let me put an a there. So a squared plus x squared equals 1 squared. So a is equal to, a squared is equal to 1 minus x squared. And since it's positive, we're just going to keep the positive root here. So this side of the triangle by Pythagorean theorem, which many of you could have done in your head. So now the adjacent leg is 1 minus x squared. And that is the cosine because it would be the adjacent leg over the hypotenuse. So this cosine of y is 1 minus, or the square root of 1 minus x squared. And now doesn't that look like what we expected for the derivative of inverse sine? So it's all a matter of using Pythagorean theorem. All right, let's try one more. Let's see if we can do a similar problem and see whether we come up with the correct formula for the derivative of arctangent. So let's start with an equation that we would use to find y prime. And now let's rewrite it in our more familiar form here. X is equal to the tangent of y. So that's what inverse means. The x is the answer and the y is the angle. And now let's do our implicit differentiation again. The derivative of x is 1. The derivative of tangent is secant squared of y with a chain rule on the y. So that would be our dy dx. So dy dx, if instead of dividing by secant squared, think of this as 1 over cosine. So if we divided 1 over secant squared, wouldn't that be cosine squared on this side? All right, so now this is certainly not the derivative we were expecting, but let's go back and look at a triangle again. So we want an angle that satisfies this equation. They're both the same. Those first two equations are equivalent. So we want to make a triangle that has an angle y, and we want the tangent of that angle to be x. So the tangent is the ratio of the opposite leg to the adjacent leg. So we would have to put x and 1 in this position to have a tangent of y that would be equal to x over 1. And then we could do our Pythagorean theorem, of course. 1 squared plus x squared equals c squared. So our hypotenuse would be, we'd have 1 squared plus x squared is equal to c squared is all I'm doing there. So our hypotenuse would be the square root. So now we know the hypotenuse. So now let's go and see if we can fill in cosine of y. Cosine of y is the adjacent leg over the hypotenuse. So there's our cosine of y. And now let's transfer it. And notice that we have to square it. Notice this squaring. So when we square that square root, there's our formula as we expected it. So we came up with the derivative of arctangent by looking at Pythagorean theorem.